In this video, we're going to look at how the electron was discovered. So, by the 19th century, thanks to Dalton and the other scientists, everyone pretty much was convinced that, yeah, things are made up of atoms. But people weren't sure if atoms were actually the smallest thing around. They were wondering if there were even smaller particles out there. And the first evidence for smaller particles was in the late 1800s by J.J. Thompson, and here is J.J. right there. Now, the way that Thompson discovered the electron was experiments looking at cathode rays by using a cathode ray tube. Now, those of you who had big TVs, CRTs, he's using the same thing that more or less powered a CRT, cathode ray tube. Now, with this experiment, he had his cathode ray tube and he had some way to give it voltage. And what he saw was when there was voltage being given, a beam of particles always traveled from the negative cathode to the positive anode. Now, for these particles, there are some interesting properties. One, this beam always traveled in a straight line. Two, it doesn't matter what made up the material, he would always see this same beam. Three, this beam carried a negative electric charge, which today we know what he was looking at were electrons. Now, just as a reminder for electrical charge, opposites attract. A positive and a negative will attract each other and come together. Charges of the same sign, that is positive and positive, or negative and negative, will repel each other. And in chemistry, when we're talking about atoms and elements with charges, if it's positive, we give them positive numbers. If it has a negative charge, we give a negative number. When a positive and a negative charge come together, their overall charge is 0 because you have a +1 plus a -1. Now, we knew that there was an electron, and Thompson was actually able to measure what the charge to mass ratio of the particles were. That is, for the overall charge, how big is this particle? He did this by taking his tube and just deflecting his beams using a magnetic field. We're not going to go into the math of how this was done, but he was able to see that, oh, these particles, these electrons, these things are actually 2,000 times lighter than helium, which means that what he was seeing wasn't atoms, but he was destroying atoms and looking at the small particles that make up atoms. Now, the next person in our story is Milliken. And what he was looking at is he was trying to figure out what the actual charge of the electron was. And he did that by using an oil drop machine, or the oil drop experiment, rather. And what he did is that he had oil, and he would use an atomizer, the same thing you can use to spray perfume or cologne. And he would atomize the oil and allow them to fall down this hole using gravity. Now, when they fell down this hole, these particles were hit by radiation to make them negative. Then, when the particles were down here, he had an electric charge going between this negative plate and this positive plate. And by adjusting the strength of these plates, you could cause this particle to hover in midair. Because remember, gravity is pulling it down, and the electric field is pushing it up. So by knowing the strength of the electric field, you could determine the charge of the negative charge. And he did this many times, and he was able to calculate the mass of the oil drops by knowing the radius and density of the oil drops. And eventually, he saw that no matter what oil particle he was using, that the charge of the drops were always a multiple of negative 1.60 times 10 to the minus 19 coulombs. That's what the C is. It's a coulomb. It's just the magnitude of the charge. So not only do scientists know that, electrons are a thing now and that they're super tiny, we also know their overall charge. And interestingly enough, even though this experiment was done over 100 years ago, and it looks pretty crude compared to the type of instruments we have today, the charge that Milliken decided on is only 0.6% different than the charge we use now, showing that this was a pretty accurate experiment. Okay, so that's all for this video. See you in the next.